Hi everybody. Today we will be solving systems of linear equations in three variables using two different methods. We're going to use linear combination, or maybe we know that as elimination, and substitution, both of which we have seen before, but it's our lucky day and we get to use three different variables, which means we start with three different equations. So in this video, I'm going to do my best to organize our steps, but there is kind of a bit of writing. So you might need to pause and rewind, and I'm going to tell you right now, you're going to benefit so much if you even watch this video more than once. So, step one, use a combination of all three equations to eliminate one variable. You have to use all three equations. So I'll show you what I mean. My first set, I'm going to use just equations 1 and 2. So that is x plus 3y minus z equals negative 11, and 2x plus, y plus z equals 1. So those are my two equations. And I chose 1 and 2. Well, I always start with 1 and 2 because I'm going to have to use them at some point. This one's easy. I'm going to choose to eliminate z because they're already ready to go. So edit, I got 3x plus 4y equals negative 10. And then I'm going to star. But I have to use all three variables to eliminate z. So that means, or all three equations, excuse me. I know I have to use equation number 3, which is 5x minus 2y plus 3z equals 21. So I either have to choose equation 1 or equation 2. I have to use one of them because I already chose 3. So in this case, I'm going to choose equation 1. So I've got x plus 3y minus z equals negative 11. I chose equation 1 because here z is negative already, and it just makes it a little bit easier. But if you chose equation 2, you would not be wrong. So to eliminate z, I need to multiply everything by 3. So 3x plus 9y minus 3z equals negative 33. And now I can eliminate z. See, 3z plus negative 3z is 0. So I have 8x plus 7y equals negative 12. And we're going to be more careful than usual about negatives and our algebra because that's going to make these problems like these impossible. So we have to be super careful. So step 2 is use our star equations to eliminate one variable. Because now if I line up my star equations, which are 3x plus 4y equals negative 10, and 8x plus 7y equals negative 12, this is exactly like the systems we've been solving the past couple days, just in two variables. So we shouldn't have any trouble solving for one now. That's easy. So I'm going to choose to eliminate x. So I'm going to multiply my top equation by negative 8 and my bottom equation by 3. So we can get them with the same coefficient. So I've got negative 24x minus 32y equals 80. And I've got positive 24x plus 21y equals negative 36. So now when I add these together, my x's cancel. I'm left with negative 11y equals 44. So easy, divide by negative 11. Y equals negative 4. So I'm going to underline that. That's already one of my solutions. We're getting there. We only have 3 steps to go. So now I get to move to step 3. I need to plug in variable, the one we just solved for, into either, oh, that's not how you spell either, star equation. So we can solve for one more variable. So you can choose either star equation, it doesn't matter. I'm going to choose the 8x plus 7y equals negative 12. So I have 8x plus 7y Well, now I know y is negative 4 equals negative 12. And then you're all gonna be really awesome and solve that. And you're gonna get x equals 2. So here's another solution. How about that? We are moving right along to step 4. We're gonna find the last variable by using any of the original equations. I don't care, again, which one do you use? Doesn't matter. Any one of them. 1, 2, or 3. Whatever you think is easiest. I'm going to use 2x plus y plus z equals 1. So I have 2 times 2 plus negative 4 plus z equals 1. And you're going to solve, because you're all awesome, and get z equals 1. So look at that. I have x, y, and z. So that brings us to our last step, which is step number 5. We need to write as ordered triple, which is always x comma y comma z, right? It's not an ordered pair in this case because we have 3 variables. It's an ordered triple. So that is, whoops, 2, negative 4, and 1. And that is my solution. You can always check your answers. You have to plug in x, y, and z to all 3 equations, and they have to work for all 3 equations in order for it to be correct. So you guys can take the time to do that. I'm going to move to example 2. So step 1. Again, use all 3 equations. So equation 1, I've got 3x plus 2y plus 4z equals 11. And equation 2 is 2x minus y plus 3z equals 4. And I'm going to need to multiply that bottom equation by 2 so I can eliminate those x's. So I'm going to rewrite both equations. 3x plus 2y plus 4z equals 11. And now I have 4x minus 2y plus 6z equals 8. So I can eliminate those y's really easily. 7x plus 10z equals 19. And that's our first star equation. If I move over here, I know I have to use equation 3, which is 5x minus 3y plus 5z equals 4. And you can decide what you want to use, equation 1 or equation 2. I think in this case equation 2 is easier. 2x minus y plus 3z equals 4. Ooh, and you know what? I wrote this one wrong. This one is 5x minus 3y plus 5z equals negative 1. See, again, you got to be super careful with these. I need to multiply my top equation by negative 3. So I have negative 6x plus 3y. See, that's why they cancel. Minus 9z equals negative 12. Add these two together. I'm at negative x minus 4z equals, negative 13. So I'm going to star that one. So now I'm over at step 2. I need to use my star equations to eliminate a variable. 7x plus 10z equals 19. And negative x minus 4z equals negative 13. So personally, I think it's easiest now to eliminate x. So I'm going to multiply this equation by 7. So first I'm going to rewrite this, the top one. 7x plus 10z equals 19. And then when I rewrite the other one, negative 7x minus 28z equals negative 91. Now again, if I'm going too fast for you, you're always allowed to pause and rewind and watch it again. So eliminate those x's. I'm left with negative 18z equals negative 72. Divide both sides by negative 18. Now z equals 4. So I'm moving right along here to step 3. I need to use a star equation to plug in z to solve. Now for this case it's x. So if I go 7x plus 10z now is 4 equals 19. 7x equals negative 21. You get x equals negative 3. Now, I want you to do step 4 and step 5. Now, I have two of the variables, so I'm going to pause, and you're going to find y. Ready? 1, 2, 3, pause. Did you get what I got? I got y equals 2. I used, let's see, equation 1, solve for y to get 2. So hopefully you got what I got. If not, I would like you to pause, rewind, and try that again. So let's move to number 3. So take a second to pause what I've written down. I only want you to use this if the directions say so, or if you already have one variable isolated, like we have here, z equals 12. So the step 1 is to substitute in the first variable. So that means I have x plus y plus 12 equals 24, and 5x plus 3y plus 12 equals 56. So my next equation is x plus y equals 12, and 5x plus 3y equals 44. So from here, you guys should know exactly what to do. We've done substitution for two variables before, so we're going to move to step 2. Isolate one more variable. So I'm going to choose this first equation, x plus y equals 12, because it's easy for me to get y alone. Y equals negative x plus 12. So I can take that and plug it into equation 2. So 5x plus 3, but now I don't want y anymore. I want negative x plus 12 equals 44. And then I can solve this equation for x. First, I'm going to distribute that 3. Then I have 2x equals 8, so x equals 4. Look at that. I have one solution. So that brings me to step 3. I need to substitute into the equation to find my second variable. Actually, it's the third, right? They gave us one to begin with. So I'm going to write third. So I need to take x and plug it back in up here. So y equals negative 4 plus 12. So y equals 8. So I've got 4, 8, 12 as my ordered triple as step 4. So substitution isn't bad, but we really truly only want to use it when we have one variable isolated. Otherwise, it does get very tricky. So example 4. A theater group sold a total of 440 tickets for $3,940. Each regular ticket cost $5. Each premium ticket cost $15, and elite ticket cost $25. The number of regular tickets was 3 times the number of premium elite tickets combined. How many of each ticket type were sold? So I'm going to label my variables. So I just quickly wrote down exactly what you were thinking. X, Y, and Z, regular tickets, premium tickets, and elite tickets. So I have 3 variables. So that means I need 3 different equations. I know that they sold a total of 440 tickets. So X plus Y plus Z has to equal 440, right? The total number of tickets. I also know that regular tickets cost $5, so 5X. Premium tickets cost 15Y. And elite cost 25Z, and we sold a total of $3,940 worth of tickets. Now the last one's the tricky one though. It says the number of regular tickets, so X, is an equal sign, 3 times the number of premium tickets and elite tickets combined. Wow. So we're going to go through the rest of this problem in class tomorrow. Now, like I said at the beginning, I want you to rewind and rewatch this as many times as you need to before we get to class. See you then.